This video is all about exam 3. I have identified what the correct answers are, so that way things will move along a little bit faster. So an online company, catalog company, wants online delivery to be at least 90% of the orders shipping on time. UPS has switched to a more expensive service, and they believe that will exceed the 90% goal. So what are we going to pick for the null and alternative hypothesis? Things like at least and exceed point us in the direction of the alternative being a greater than. The null hypothesis always has an equal sign, and it represents what the online company thought in the first place, not what UPS is doing. All the others have a real problem because at least 90% should be in the mix. This is an alternative, not a null hypothesis. Alternative, not a null. This is a sample proportion, and this 93 is what UPS put out there as a number. In the 1980s, it was generally believed that congenital abnormalities affected 5% of the nation's children. A recent study was conducted, and 12% of them showed an abnormality. What hypothesis should we use to test that the risk has increased? Okay, increased is a key word. So the number that they put out there is going to be our null hypothesis, 0.05. And has the risk increased? The word increased is pointing us in the direction that the alternative is a greater than. As a side remark, the alternative can be three things. It can be greater than, less than, or not equal to. Sample of 50 cars in a fleet, 25% failed to meet pollution guidelines. Which hypothesis could be used to test this evidence that more than 20% of this fleet are out of compliance? Again, we're supposed to test the hypothesis that 20% of them are out of that's the hypothesis we're supposed to use, out of compliance. So the null is clear. Is it 20%? Or if you're out of compliance, that means it's more than 20%. Okay, there's not even a not equal to or a less than in the mix for alternatives. Airlines Public Relations Department says that whenever luggage is lost, 90% of it is recovered within 24 hours. A consumer group surveyed 122 people and found that 84% were reunited with their luggage in the next day. What hypothesis can be used to test if there is evidence that less than 90% are returned within 24 hours? The less than is a key word. So 90% is the number that's floating out there as what we're testing. And the evidence we're testing, is it less than 90%? Comes right out there, test that it's less than 90%. All the other things have problems. That's sample, that's an alternative, that's a part of an alternative, and the 84%, God knows where that came from. Okay, so we picked the correct selection here. College Board reported that 57% of the students who took the AP Stat exam earned a score of 3 or higher. In one high school, 54 took the AP exam, and in that high school, 65% got 3 or higher. Which hypothesis could be used as evidence that the students in this school showed higher than the national figure? Higher than is a greater than. Higher than is the word we need to focus on. So is it the 7% that the College Board claimed was the correct number? So is the proportion 57% what the College Board said? Or is it higher than 50%, as evidenced by the data that the high school took? Online catalog company wants online delivery for at least 90% of the orders that it ships. They've switched to UPS, which is more expensive. A company sends out random orders via ShipFast and makes 100 phone calls. And after they ran their test, their hypothesis test, the p-value was 0.158. That's not good. Okay, it is less than 0.05 is the usual criterion in order for you to reject the null hypothesis. So the null hypothesis would say that the ship rate is 90% versus the ship rate is more than 90%. Well, they were not able to reject that null hypothesis, so there's no reason to contradict the catalog's claim of 90%. Here we go. There's no evidence that a higher percentage arrived on time using ShipFast. This no evidence means we did not reject that we did not reject the null hypothesis. There wasn't enough evidence to claim that ShipFast was faster. I want you to look for this phrase, there is no evidence. When a p-value does not meet the criterion that is less than 0.05, That's the way you start your conclusion. There is no evidence, blah, blah, blah. I don't even want to look at the distractor responses. I think we're just going to move along. In the 1980s, it was generally believed that congenital abnormalities affected 5% of the nation's children. A study was done that found 7% showed signs of abnormality. This time the p-value was 0.03. That is less than 0.05. So we will be able to reject the null hypothesis. And let's see, there's a higher proportion than the 1980 figure. Apparently the alternative is a study examined children and found them having a 7%. And so I guess, if anything, the proportion is higher than it was in 1980. And all of the distractor responses don't hit the target at all. And by the way, whenever you reject a null hypothesis, that's a bold thing. You have to quote your p-value, which is the probability that it was incorrect for you to reject the null hypothesis. Maybe this is called a type 1 error. Maybe you rejected a null hypothesis that was actually true. That's called a type 1 error. So there's only a 3% chance that you made a type 1 error. Company sampled 50 cars in their fleet. 25% failed to meet the pollution guidelines. A test of significance was conducted to see if it provided evidence that more than, that's a key phrase, 20% were out of compliance. So the alternative would be more than 20%. But unfortunately, that test of significance had a p-value that was not less than 0.05. So what are we going to start our conclusion with? There is no evidence from this data to indicate that more than 20% of the cars are out of compliance with pollution guidelines. So if the p-value is not less than 0.05, you always start your conclusion this way. There is no evidence. College Board reported that 57 of the students who took the AP exam, STAT exam, scored 3 points or higher. In one school, 54 students got 65% scoring 3 or higher. A test of significance was done, and the p-value is less than 0.0, was 2.46, not less than 0.05. We're not able to reject the null hypothesis. There is no evidence that there's anything different in this high school. The College Board 57% holds. Here we go. If you don't reject the null hypothesis, if p is not less than 0.05, you start it off this way. There's no evidence from this data that students in this high school had a higher percentage scoring 3 or above. A company set a goal of developing a battery that lasts at least 5 hours, which is 300 minutes, in continuous use. So a test was conducted on these batteries, and it came up with 306 minutes, a little bit higher. So which hypothesis could be used to test the company met its goal? So to meet its goal, it has to last at least 300 minutes, which means 300 minutes or more. So the alternative is a greater than. The company claims that it lasts 300 minutes or more. So that phraseology points us in the direction of an alternative that's a greater than. A large university believes that students take an average of at least 15 credit hours per semester. So we ran a study, we got a certain mean and standard deviation. Which hypothesis could be used to see if the professors are incorrect? Okay, so let's look at this again. The students on average take at least 15 hours. The at least is the phraseology that's going to point you in the direction of the alternative, meaning they take 15 hours or more. So the alternative is a greater than. An insurance company knows that last year the life expectancy of its policyholders was 77 years. They want to know if their clients this year have a longer life expectancy, so they do a study. So they want to know if they have a longer life expectancy. So always go with what the insurance company says. That's what you're challenging. So you're challenging, is the insurance company correct, or the data that was collected wants to know if, what does it say? Living longer than last year. Longer than last year is the phraseology that points you in the direction of a greater than. So you have to look at the wording very carefully. Manufacturer of a new portable phone claims that it has a range of 150 hours, allowing customers to use their phone throughout their home and yards. An independent company that has certain kind of data, let's see, has a range of, now if you have a range of 150, I guess we're just there's nothing that says lasts at least 100 yards. So the challenge is it different than 150? Here we go. A manufacturer claims that a certain brand of tire will allow a car traveling 60 miles an hour to stop within 125 feet. You collect some data. Which hypothesis is used to test that the claim is false? False. So they're putting out, the manufacturer is putting out that number, it stops in 125 feet, and we're testing the claim that it's false. So that would be a not equal to alternative. A company is developing a battery that lasts 300 minutes in continuous use. A test of 12 of these batteries, this is again a problem involving means. What test of significance? Oh, the test of significance wound up having a p-value of 0.493. Bad news, it's not less than 0.05, so there is no evidence that the battery life is, the claim of the battery life lasting 300 minutes is incorrect. We did not reject the null hypothesis, which says it lasts for 300 minutes. A professor at a large university believes students take on average at least, look at that, that's an important word, 15 credit hours per semester. A random sample of 24 students in the class. This is again, something you'd have to use StatCrunch to come up with your p-value. But after running it through StatCrunch, the p-value turned out to be 0.002. It is less than 0.05. We are going to reject the null hypothesis. This says at least. So we are going to say the average credits per semester does exceed 15. So we're accepting, we're not rejecting the null hypothesis. It could be true. And the p-value is 0.002. And that's basically saying there's less than a 0.002% chance that we were incorrect in rejecting the null hypothesis. We're getting there. Number 17. Tire manufacturer claims that a certain brand of tire will stop within 125 feet. Here's some data. A test of significance produced a p-value of 0.547. Bad news, it's not less than 0.05. So we cannot reject the null hypothesis. So, started off with, there's no evidence that the average stopping speed is anything different than what the manufacturer claimed. The manufacturer's claim could be true. A large study of aspirin showed that aspirin reduced the first heart attack by 44%. A pharmaceutical thinks they have a drug that's more effective. What null hypothesis should they use? They should use they should go with what the large study put out there. All of these are not null hypotheses. They are alternative hypotheses. Why? Because the null hypothesis always has an equal sign. What could be a null hypothesis? Not this, not this, not this. Why? Because the null hypothesis always has an equal sign. Which one is not a possible alternative? Yeah, it could be less than, it could be not equal to, could be greater than, but you can't have your cake and eat it too. This says less than or equal to. That's not acceptable. So the first three are, this one is not. The last problem. Reject the null hypothesis if the p-value is what? Small enough. That's what you would pick from the drop-down menu. Well, I hope this helped. The disclaimer is, the MyMathLab authors of these problems make sure that everything is as random as it can be, including the numbers in the problem, whether or not you'll see a particular problem or not. They'll change a p-value. So what you need to take out of this video is, I hope you get the big idea. You will not get exactly these problems in exam 3, but you will get problems very similar to this in exam 3. So that being said, I hope this helps, and I will post it. I'll post it in the last module on Canvas, the week 6 module, and I will send you a link to the video as well in your email. Okay, thanks for watching.